On a cold December night in 1941, the United States confronted a grim arithmetic it had spent years trying not to see. The nation had been pulled into a global war for which it possessed neither the scale nor the momentum. Its armed forces remained modest, its doctrines incomplete, and its attention divided between oceans that suddenly felt far narrower than they had in the months before Pearl Harbor. What emerged in those early winter hours was not panic, but the sober recognition that the world had shifted faster than American industry had prepared to move. In scattered depots and armories, stockpiles revealed the uncomfortable truth of a country long sheltered by geography. America possessed ideas, plans, and prototypes, yet few of them existed in numbers that could shape a battlefield. Tanks were limited, aircraft insufficient, and munitions stored in quantities that matched a different era. The gap between intention and capacity lay exposed, a reminder that modern war rewarded those who had prepared before the first shot, not after. Across the Atlantic and Pacific, Germany and Japan filled headlines with evidence of their industrial discipline. Factories in Essen, Hamburg, Osaka, and Nagoya poured out steel and explosives at a pace that suggested inevitability. Their arsenals were not theoretical. They were functioning machines geared toward conquest. To American observers, the comparison was stark and the consequences unmistakable. Yet in the quiet hours before dawn, American factories stood dark, their machines still, their workers home. Not one of them knew how violently the silence was about to end. These buildings, unremarkable brick structures scattered across the Midwest and Northeast, would soon reshape the trajectory of the conflict, though in that moment they remained ordinary. Then came Roosevelt's call, production levels no democracy had ever imagined, much less attempted. His numbers sounded impossible, planes by the tens of thousands, ships by the hundreds, tanks in steel columns that stretched beyond any existing assembly line. Economists warned that such demands defied capacity. Generals worried that even extraordinary effort might prove inadequate, but the challenge was issued. And so the arsenal of democracy emerged first as a promise, fragile and untested, waiting for the machinery that would bring it to life. In the next section, that machinery would begin to turn. When Roosevelt announced his aircraft goals in early 1942, they did not resemble policy so much as prophecy. He spoke of planes in quantities that exceeded the world's total output, numbers that eclipsed the combined annual production of every major power. To many listeners, the figures felt detached from the nation's known capabilities, as though the president were asking the country to leap across a chasm without measuring the distance. Yet his voice carried the steady cadence of a man who understood that hesitation would cost far more than ambition. Critics responded with an argument that sounded reasonable on the surface. American industry was too dispersed, too rooted in peacetime habits, too accustomed to comfort to transform overnight. Factory towns were scattered across states, staffed by workers who had never imagined building weapons for a global conflict. Many industrialists warned that the country lacked the concentrated manufacturing corridors that Germany and Japan had already forged. The skepticism was not born of defeatism, but of arithmetic. Then came the shock of early Allied defeats. Reports from the Philippines, Malaya, and North Africa cut through every assumption of gradual mobilization. The pace of enemy victories added new weight to the president's demands, turning what had seemed ambitious into what now felt essential. The United States could not afford production that merely kept pace. It required output that overturned the logic of the war. In engineering offices from Detroit to Buffalo, men and women began sketching the true scale of the challenge. Assembly lines had to be redesigned, supply chains rebuilt, and materials reallocated in quantities that strained every known model. The blueprints revealed not only technical complexity, but the burden of time itself, an enemy that did not negotiate. Across the country, ordinary citizens listened to radio broadcasts describing retreats, bombed harbors, and dwindling Allied positions. The voices crackling over the airwaves carried a sobering message. This conflict would not be decided solely by battles abroad, but by decisions made in American towns still adjusting to blackout curtains and ration books. Gradually, the nation understood that production was no longer an economic calculation. It was an act of survival. Factories became front lines. Workers became the tempo of strategy. And every report of loss made the distance between what America possessed and what it required feel more perilous. That gap would soon become the force that reshaped the entire mobilization effort. an opening that the next section will watch begin to close. In the first months of mobilization, America's industrial leaders faced an uncomfortable admission. They had no blueprint for military mass production. Their factories were monuments of peacetime innovation, designed for consumer cycles and predictable markets, not for the relentless tempo of global conflict. Many executives understood engines, refrigerators, and stamped steel car bodies, but few had ever studied the specialized demands of armored vehicles, aircraft assemblies, or precision sights expected to function in Arctic cold and desert heat. The absence of a plan was not a failure of intelligence, but the consequence of a nation that had long believed distance equaled safety. The tooling shortages made this reality unavoidable. Before a single tank or aircraft could be assembled, entire layers of machinery needed to be built. Presses, jigs, dies, furnaces, and gauges manufactured in quantities no company had anticipated. Even the most experienced engineers warned that producing the machines to build other machines would consume years, time the world did not intend to grant. It became clear that war production required an industrial foundation, as complex as the weapons themselves. Workers who had once shaped steel for cars and home appliances now faced drawings for weapons they had never seen. Riveters accustomed to automobile chassis were asked to meet tolerances measured in fractions they had never used. Foundry teams who once cast decorative parts for consumer goods were now responsible for armor plates meant to withstand cannon fire. Their transition formed a silent, human front line, where familiarity yielded to urgency. Complicating the effort was the uneasy relationship between the military and private industry. The armed forces spoke in specifications and field requirements. Manufacturers spoke in tooling schedules and material limits. Each side carried assumptions that the other found bewildering. Misunderstanding was inevitable, and initial production schedules began collapsing under the weight of unrealistic expectations. Delivery dates slipped, prototypes failed, and early assessments warned of catastrophic delay. Roosevelt's challenge, once framed as a matter of factories and steel, revealed itself as a test of imagination. Success demanded not only machinery but reinvention, a willingness to reimagine how a nation could build at a tempo history had never witnessed. America now stood at the edge of the largest industrial gamble in human history. In the next section, that gamble would begin to take shape. In the winter of 1942, as the nation searched for direction, Detroit stepped forward with a confidence that bordered on declaration. Automobile executives, men who had spent decades perfecting the rhythm of mass production, insisted that they could convert their factories faster than any government planner dared to predict. They had built empires on speed, efficiency, and repetition, and they believed those same principles could be fused into the machinery of war. To them, the industrial crisis was not a warning but an invitation, proof that the future belonged to those who moved first. Among these voices, none resonated louder than Ford. The company that had once transformed manufacturing with the moving assembly line now claimed it could apply the same logic to aircraft production. Henry Ford's spokesman announced that bombers could be built like automobiles, in a continuous flow, each worker mastering a single motion, each station synchronized to the next. It was a radical concept. No nation had ever attempted to construct aircraft, complex machines of aluminum and wiring, using the template of automobile mass production. Yet Ford presented the idea with the calm assurance of a company accustomed to redefining what was possible. Skeptics quickly pointed out the gaps between ambition and engineering truth. Airplanes demanded tolerances far beyond anything expected of a car. A misaligned panel on an automobile created noise. A misaligned panel on a bomber could tear free at altitude or compromise aerodynamics just enough to cost a crew its life. Rivets that held under the steady stress of a highway could fail under the shifting forces of air pressure and vibration. And where automobiles could accept small variations from part to part, aircraft required precision that bordered on the mathematical. Inside factories now designated for conversion, engineers argued over everything from rivet patterns to rates of metal fatigue. Drawings arrived in stacks, demanding solutions that collided with buildings designed for speed, not delicacy. The rituals of automotive production, quick stamping, fast welding, rapid movement down the line, were suddenly incompatible with the measured discipline required for aviation. Conference rooms filled with debates that stretched late into the night, each decision carrying consequence. Far beyond Detroit, At stake was not merely efficiency, but the reliability of machines meant to operate thousands of feet above the earth, in combat conditions no car would ever face. Yet Detroit's confidence became a national story, a symbol of belief that bordered on arrogance. Newspapers wrote of executives who claimed they could outpace government deadlines and defeat traditional manufacturing logic. Radio broadcasts celebrated the idea that American ingenuity alone might overcome time, distance, and complexity. For a country still adjusting to war, Detroit's voice offered something intoxicating, the suggestion that victory might be engineered rather than endured. Privately, military officers studied these promises with restrained skepticism. They admired the optimism but doubted its durability. Many believed the first deadlines would collapse under the weight of technical reality. They worried that the automobile giants, accustomed to perfection on their own terms, had underestimated the demands of global war. In their view, ambition was valuable, but not enough. And so the stage was set for a collision between vision and necessity, between the bold declarations of Detroit and the unforgiving mathematics of wartime production. In the next section, the consequences of that collision would begin to reveal themselves. The first step toward order came not from a factory floor, but from Washington. Faced with a spiraling maze of specifications, competing designs, and incompatible parts, the government issued a directive that cut to the heart of American industry: standardization across all branches of the armed forces. In an era defined by invention, the command sounded almost heretical. Yet without a common language of production, the country risked drowning in its own creativity. The directive signaled a shift from improvisation to coherence, from scattered effort to national discipline. This new reality struck hardest at companies long accustomed to guarding their proprietary designs. For decades, competition had been their engine. Blueprints were trademarks, symbols of corporate identity, evidence that their engineers could solve problems no rival had mastered. Now, those closely held documents were to be shared across firms, enabling manufacturers to produce one another's components without hesitation. Factories separated by thousands of miles were expected to build parts that fit together on the first try, as though designed under one roof. It was a cultural upheaval disguised as an administrative requirement. For many engineers, the transition carried an emotional weight often overlooked in wartime histories. These were individuals trained to push boundaries, rewarded for originality and refinement. To ask them to surrender innovation for efficiency felt at first like asking them to step backward. They confronted the realization that the war demanded not the perfect design, but the producible one, the aircraft that could be built 10,000 times, not the prototype polished to flawless singularity. The adjustment required discipline not of the hands, but of the ego. Within the aircraft industry, the lesson became unmistakable. Interchangeable parts, once an aspiration unevenly applied, had to become a universal standard. Wings, fuselage segments, control systems, and engine mounts needed tolerances so consistent that an assembly built in California would align perfectly with components cast in Illinois. Achieving this required rewriting not only drawings but expectations. Precision, once the pride of a select few companies, had to become the norm for all. The War Production Board emerged as the referee of America's industrial identity. Its officials mediated disputes, enforced standards, and overruled decisions when necessary. They listened to executives defend long-standing methods and then instructed them to adopt new ones. They navigated technical feuds that blended engineering philosophy with personal pride. In doing so, the board became the quiet architect of a national transformation, shaping a system where corporate rivalry no longer hindered the war effort, but strengthened it. Gradually, a new belief took shape, that rational planning could overcome even the starkest shortages. If parts could be shared across factories, if designs could be simplified without sacrificing performance, then the nation could multiply its capacity without multiplying its facilities. Efficiency became a weapon, just as vital as steel or fuel. The blueprint, refined and standardized, became a tool of strategy. By the end of 1942, the United States committed itself to production goals that reached beyond the war, toward an industrial future no previous generation had imagined. The decisions forged in these months would reshape not only the conflict, but the global economy that followed. And in the next section, the first signs of that transformation would begin to reveal their true scale. As millions of America and men left for the front, the country confronted a new kind of vulnerability, not on distant battlefields, but in the factories that fed the war machine at home. Entire shifts vanished overnight, leaving assembly lines half-staffed and production schedules in disarray. Machines that once hummed through predictable days now sat motionless, waiting for hands that would not return. The United States suddenly faced a labor crisis at the very moment it needed more workers than at any time in its history. The paradox was unmistakable. To wage war abroad, the nation first had to rebuild its workforce at home. Into this vacuum stepped an army the country had not expected. Women entered factories in numbers that rewrote social norms, taking up roles once considered the exclusive domain of men. They learned to lift engine blocks, operate milling machines, and rivet the skin of aircraft that would soon cross oceans. Their uniforms were denim and leather aprons, their tools wrenches and pneumatic guns. What had begun as necessity evolved into a quiet revolution, altering forever the composition of the American workforce. The war demanded strength. They supplied it without hesitation. Yet their arrival did not resolve the deeper challenge, speed. The war allowed no luxury of time. Training that once unfolded over years had to be compressed into weeks. In hastily arranged classrooms beside factory floors, instructors taught metallurgy, machining, and electrical systems at a tempo that strained every participant. Mistakes were expected. Mastery was required. The learning curve became a race, measured not in tests, but in parts delivered and deadlines met. Amid this influx of new labor, immigrant communities found themselves thrust into vital roles. Many carried skills from old-world trades, fine metalwork, tool-making, precision machining, that American industry had quietly allowed to diminish. Their expertise bridged the gap between raw enthusiasm and technical demand, turning workshop experience from Europe, Asia, and Latin America into strategic advantage. In the mosaic of accents that filled the factory air, the war effort found a reservoir of knowledge it had not known it possessed. The introduction of night shifts further transformed the national tempo. Factories that once rested after sunset now glowed through the darkness, their windows shimmering like small constellations across the industrial landscape. Machines ran without pause, creating a continuous rhythm that echoed the urgency of the front lines. The distinction between day and night blurred. What mattered was output. The nation began to understand that war was not measured in hours, but in endurance. As the workforce settled into this new reality, a belief took root along the assembly lines. Workers, whether newly trained or seasoned by years of craftsmanship, began to see their labor as a form of service, a contribution no less vital than combat. Each completed engine, each welded hull became a quiet assertion of purpose. Their tools were not rifles, yet the responsibility they carried felt no less weighty. Slowly, almost imperceptibly at first, production numbers began to climb. Factories that had once struggled to meet minimum quotas now edged upward toward the impossible goals Roosevelt had announced months earlier. Morale rose with every completed aircraft and every finished tank, proof that the nation's makeshift army of workers had become something more than a temporary solution. And as their confidence grew, it prepared the country for the next transformation, one that would test whether this new industrial momentum could withstand the full pressure of global war. Ford's Willow Run bomber plant was meant to be the triumph that proved Detroit's promises were more than rhetoric. Conceived as the largest factory in the world, its mile-long assembly line was designed to roll out B-24 Liberators with the same rhythm that had once sent Model TS onto American roads. But as the first months of operation unfolded, Willow Run became something else entirely. A monument to delay, frustration, and the sobering realization that wartime ambition could not be willed into existence. Catastrophic schedule slips sent shockwaves through Washington, reminding observers that even the most confident industrial prophecy was vulnerable to the physics of aluminum, steel, and human limitation. As engineers walked the length of the plant, they found that aircraft production resisted the familiar logic of the automobile in ways they had underestimated. Cars tolerated minimal variation, bombers did not. Where a vehicle frame could absorb a slight difference in the curve of a panel, the B-24's complex geometry demanded absolute consistency. Its wings carried thousands of rivets, each placed with precision. Its fuselage sections required alignment across dozens of structural points, each dependent on the one before it. The moving assembly line, Ford's signature innovation, struggled to accommodate these realities. What had once been a symbol of speed became a series of halting movements, the line inching forward only to stop again when a part refused to fit. Misaligned components became the factory's daily antagonist. One section arriving even a fraction off spec forced the entire line to freeze while mechanics adjusted, remeasured, or restarted entire assemblies. Workers who had spent their lives in automotive plants found themselves wrestling with tolerances measured not in inches but in thousandths. Retooling became constant. Jigs were rebuilt. Dies were scrapped. Hours dissolved into days as teams raced to correct errors that cascaded across the line in ways no one had predicted. Each stoppage ate into schedules already collapsing under wartime pressure. The skilled labor shortage compounded every challenge. Precision riveting, intricate wiring, and delicate machining required hands trained through years of experience, hands now fighting in North Africa and the Pacific. Their absence left critical tasks in the care of newly trained workers performing at the edge of their ability. Supervisors watched apprentices learn under stress that offered little room for mistakes. Every mise-drilled hole or improperly set rivet multiplied the hidden weaknesses inside the structure of a bomber meant to withstand combat. The shortage became not simply a logistical problem, but a human one, demanding patience in an environment ruled by urgency. Management soon confronted the psychological toll that settled across Willow Run. The plant had opened under a banner of confidence. Now it carried the weight of expectation unmet. Engineers pacing the catwalks felt the burden of responsibility for every stalled station. Foremen struggled to maintain morale as workers absorbed the growing sense of failure. The factory's scale, once a source of pride, magnified each setback. It became clear that industrial optimism alone could not compensate for the reality of constructing one of the most complex aircraft of the war. When the early B-24s finally emerged from the plant, the setbacks became visible in steel. Delivered late and riddled with defects, the first aircraft required extensive rework at modification centers before they were considered airworthy. Reports detailed wiring errors, fuel system inconsistencies, and structural weaknesses that prevented full operational use. These problems forced the military to divert resources toward repairing what industry had built too quickly. The promise of high-volume production, thousands of bombers pouring off the line, seemed to drift further from reach with each flawed delivery. And yet, in the midst of this struggle, an important truth began to crystallize. Speed alone could not win the war. The rhythm of automotive manufacturing had to be subordinated to the precision of aviation. Every delay, every misaligned part, every halted section of the line forced a reevaluation of priorities. Accuracy became the prerequisite, speed the reward. The transformation required was philosophical as much as mechanical. Willow Run had tried to impose motion on a process that required mastery. By the spring of 1943, the lesson had become unavoidable. The nation realized that the dream of bomber mass production would demand not just larger factories, but a deeper reconciliation between ambition and reality. And in the next section, the response to these failures would push American industry into a new phase, one that sought not shortcuts, but solutions. In the wake of repeated delays and mounting defects, American engineers recognized that the path forward required more than determination. It required reinvention. The war had exposed the limits of improvisation, pushing designers and factory planners to reimagine how work itself was performed. Across the nation, blueprints were revised not only for the machines being built, but for the methods used to build them. The central goal became clear. Workflows had to be redesigned so that human error was no longer a constant threat, but a controlled variable. Assembly sequences were simplified, fixtures reconfigured, and tasks reorganized so that even newly trained workers could achieve consistency. Under pressure, American engineering acquired a new discipline, one defined not by the elegance of design, but by the reliability of repetition. Within this transformation, women found themselves excelling in roles once believed too delicate for mass production. Precision welding, critical for airframes, tank hulls, and ship components, required a steadiness of hand and an attention to detail that many supervisors had underestimated. As the months progressed, it became evident that these workers were not simply filling vacancies. They were raising the standard of craftsmanship. Inspectors reported fewer warps, cleaner seams, and welds that held firm under stress tests that had once revealed structural weaknesses. The discovery carried moral weight. IT demonstrated that wartime necessity had revealed capabilities long ignored, reshaping the nation's understanding of who could build its most advanced machines. To complement these emerging skills, production plants began adopting statistical quality control methods, techniques still new to American industry. Sampling, measurement charts, and tolerance tracking replaced intuition as the measure of reliability. Instead of reacting to flaws after they appeared, engineers learned to anticipate their sources, adjusting processes before mistakes cascaded across an assembly line. These tools introduced a new kind of visibility into complex factories, allowing teams to diagnose weaknesses buried deep within production. It was a quiet revolution, one that shifted the focus from correcting errors to preventing them outright. Meanwhile, machine tool companies confronted their own monumental assignment, producing the tools that would enable mass war production. Lathes, presses, milling machines, grinders, each had to be built in quantities that dwarfed peacetime demand. The scaling of this sector became a triumph of engineering multiplication. Toolmakers expanded their plants, hired thousands of workers, and redesigned their own machinery to withstand the strain of non-stop wartime use. Their success created the backbone of the American arsenal, for without tools, even the most efficient factory remained inert steel and concrete. In the nation's shipyards, another innovation quietly reshaped production. Modular assembly, breaking a vessel into prefabricated sections built simultaneously, allowed workers to construct entire ship segments long before they ever touched the slipway. These modules were then lifted into place, welded together, and sent down to the water at speeds that astonished foreign observers. What once took months now took weeks, in rare cases, days. The process did not merely accelerate shipbuilding. It demonstrated the power of dividing vast tasks into manageable, parallel efforts. Aircraft factories, faced with their own alignment crises, embraced jig-based construction as the solution to the geometry that had confounded earlier attempts. Massive steel frames held fuselage segments, wing spars, and control surfaces in exact positions while workers performed their tasks. The jigs created an artificial precision that human hands alone could not maintain, ensuring that parts built on opposite sides of the factory, or opposite ends of the country, would fit together flawlessly. With each new jig installed, the assembly line gained a measure of stability, turning a once chaotic system into one that could finally be trusted. Gradually, these scattered breakthroughs began to merge into something larger than any single factory or sector. What had started as a desperate, uneven mobilization now evolved into a coordinated industrial machine. Processes aligned across regions, quality stabilized, output increased not through bursts of effort, but through the smooth continuity of systems refined under pressure. The American war economy, once defined by uncertainty, started to acquire momentum that could be measured not in promises, but in production statistics. And as this momentum grew, it prepared the nation for the next challenge, one in which efficiency alone would no longer suffice, and output would need to rise to levels few had believed attainable. As American factories gained rhythm, they encountered a new obstacle, one far more fundamental than tooling or training. Raw materials, the unseen foundation of every weapon and vehicle, became the true bottleneck of industrial warfare. Steel, oil, rubber, copper, aluminum, each existed not as an endless reservoir, but as a finite resource strained by a conflict that demanded more of everything, everywhere, all at once. The realization struck with the weight of a quiet revelation. No matter how efficient the assembly line became, it could not outpace the supply of the earth itself. The war would now test not only America's ingenuity, but its ability to marshal the essential substances of modern power. The crisis sharpened when Japanese conquests swept across Southeast Asia, severing the global supply of natural rubber. More than 90% of the world's production had come from plantations now under enemy control. Without rubber, aircraft tires cracked, vehicle seals failed, and electrical insulation became dangerously unreliable. The loss threatened to immobilize the very arsenal America was struggling to build. In response, the government launched an unprecedented investment in synthetic rubber, an experimental field suddenly thrust into national emergency. Chemists, engineers, and industrialists collaborated with an urgency rarely seen in civilian science. By 1944, the United States was producing more synthetic rubber than the world had produced naturally before the war, transforming scarcity into a strategic advantage created in laboratories and refineries. L2 became a frontier of necessity. Mills from Pittsburgh to Gary pushed their furnaces to temperatures once considered unsafe, demanding output that previous generations would have deemed reckless. Night skies glowed red as molten metal poured into molds, the heat reflecting off clouds like distant storms. Engineers calculated the limits of their blast furnaces and then pressed beyond them, finding new efficiencies in ore processing and fuel mixtures. Every ton of steel carried a silent momentum into tank hulls, ship keels, and artillery barrels, and each furnace became a heartbeat of the war economy, pulsing faster with every month. Oil production surged alongside steel's ascent, expanding at a pace that reshaped the North American landscape. New pipelines crossed the continent like veins laid over mountains and plains, linking Texas oil fields with refineries and ports thousands of miles away. The most ambitious of these, the Big Inch and Little Big Inch, delivered crude and refined products across vast distances once thought beyond safe transport. Their creations signaled a shift in American strategy. Mobility itself became an industrial act, powered by the continuous flow of energy beneath the nation's surface. Without this expansion, aircraft would have stalled, convoys would have thinned, and armored divisions would have ground to a halt. As the war deepened, chemists explored new alloys to address the conflicting demands of strength and manufacturability. Aircraft required metals that resisted fatigue but remained light enough for flight. Tanks needed armor that could endure impact without becoming brittle. Each alloy represented a compromise between physics and production, between what science made possible and what factories could reliably reproduce. These materials allowed thinner wings, stronger barrels, and more resilient engines, embedding scientific discovery into the very structure of America's war machines. Supporting these advances was a logistics system that evolved into a science of movement and prioritization. Railroads, shipping lanes, and trucking routes became carefully orchestrated pathways in which every shipment carried strategic value. Dispatchers distinguished between materials needed today, tomorrow, or next month, ensuring that no assembly line waited for a single missing part. Warehouses became nodes in a vast network, balancing supply with the shifting needs of dozens of military branches and thousands of factories. The scale resembled something organic, a national bloodstream circulating resources at the tempo of war. By 1943, innovation extended far beyond the walls of any factory. It reached into mines and refineries, laboratories and shipping yards, rail hubs and river ports. The entire industrial infrastructure of the United States, raw materials, energy, chemistry, logistics, had become a coordinated engine, each part reinforced by the others. This was not simply production, it was transformation. And as the system matured, it prepared the nation for a new phase of the conflict, one in which the limits of material supply would shape the very strategies of the war still unfolding. By the dawn of 1943, the numbers told a story even the most confident planners had not dared to imagine. For months, Roosevelt's wartime goals had hovered in the national consciousness like distant stars, visible, inspiring, and seemingly unreachable. Yet the reports emerging from factories, shipyards, and foundries revealed a transformation so dramatic that it challenged the limits of belief. Production figures did not merely meet expectations, they eclipsed them. Aircraft, tanks, artillery, trucks, and ships poured into military inventories at a pace no democracy had ever achieved. Roosevelt's most optimistic forecasts now appeared conservative. What had once been a nation scrambling to prepare was becoming something entirely different, the largest industrial force the world had ever seen. Symbolizing this shift was Willow Run, the same plant that only months earlier had embodied delay and frustration. After relentless redesigns, new training regimens, and an uncompromising focus on precision, the assembly line finally achieved the rhythm Ford had envisioned. In one of the most striking accomplishments of the war, Willow Run reached its goal, assembling a Liberator bomber every hour. The sight of B-24s rolling out of the vast hangar, wingtip to wingtip, engines gleaming under factory lights, became a spectacle of industrial determination. The line that once faltered now moved with steady confidence, proof that mistakes had been transformed into mastery. Shipyards offered an equally astonishing testament. Liberty ships, once requiring months to build, were now launched in mere weeks, sometimes days. The pace astonished Allied commanders accustomed to the slow rhythms of naval construction. Vessels slid into the water so frequently that christening ceremonies became almost routine. What matter? D was not ceremony, but continuity. Each ship meant another convoy protected, another supply line reinforced, another step toward the logistical supremacy the Allies desperately needed. The Atlantic, once threatened by U-boat wolf packs, began to tilt in favor of the side that could replace ships faster than they could be sunk. Within the halls of the Army General Staff, a quiet but unmistakable shift took place. Officers accustomed to rationing ammunition, fuel, and vehicles now observed a surplus where there had once been scarcity. For the first time in the conflict, logistics exceeded consumption. Boxes of rations filled depots, warehouses overflowed with spare parts, airfields brimmed with replacement aircraft ready for deployment. The United States had crossed a threshold invisible to the public but deeply consequential to war planners. Production no longer strained to meet demand. It now drove strategy. The imbalance between American and German vehicle output became one of the most telling measures of this new reality. In months, the U.S. Army received more trucks, jeeps, and armored vehicles than Germany produced in entire years. Mechanization, once the hallmark of German blitzkrieg, now belonged decisively to the Allies. Supply columns lengthened, divisions became more mobile, entire campaigns were planned around the ability to move faster and farther than any opponent could match. The American soldier was no longer defined by scarcity, but by the machinery that carried him forward. This abundance reshaped Allied air strategy as well. For the first time, air forces planned campaigns not on the basis of what they could afford to lose, but on the basis of what they could deploy. Bomber crews trained in aircraft built only weeks earlier. Fighters were replaced with models fresher than those returning from missions. Maintenance crews worked with spares that had once been rare and now arrived in crates stacked high on runways. Scarcity had dictated caution. Abundance now enabled ambition. Long-range missions, once considered too costly, became essential components of the air war. By the end of 1943, the transformation was unmistakable. American industry no longer operated in the shadow of doubt. It had moved beyond promise, beyond potential, into a realm of dominance that reshaped the global balance of power. The arsenal of democracy, once a fragile idea, had become a physical force measured in steel tonnage, barrels of fuel, and the ceaseless hum of machines working around the clock. Yet even at this height, the question lingered. How would this unprecedented industrial momentum shape the final years of the war still to come? By late 1943, American production no longer flowed merely into U.S. depots and staging grounds. It poured outward, across oceans, across continents, across the narrowing spaces where Allied fortunes still hung in the balance. Lend-Lease deliveries, once tentative, became an avalanche. In Britain, docks filled with crates of engines, aircraft crates stacked like cathedral walls, and columns of trucks stretching along fog-covered roads. In the Soviet Union, freight trains rumbled eastward bearing canned food, boots, telephone wire, tank engines, and locomotives. This was no longer aid in symbolic amounts. It was the logistical transfusion of entire nations. Allies fighting for survival were now sustained by a distant industrial power whose strength had begun to feel almost atmospheric, everywhere and inexhaustible. The Soviet Army, in particular, felt the shift in ways that defied earlier pessimism. Through the grim years of retreat, Soviet mobility had often depended on the endurance of men and animals. But American vehicles, Studebakers, Fords, Dodges, arrived in numbers that altered the tempo of whole offensives. Long columns of trucks moved artillery, ammunition, and winter clothing faster than any horse-drawn convoy could imagine. U.S. locomotives rebuilt shattered rail networks, enabling Soviet planners to shift divisions with unprecedented speed. This mobility, quiet in appearance and humble in form, became a force multiplier that extended the reach of Red Army advances deep into territory once controlled by the Wehrmacht. The story of Soviet resurgence could no longer be told without acknowledging the machinery that carried it forward. In North Africa, the material imbalance appeared even more starkly. Here, for the first time in the war, American logistics met Axis planning on open ground and decisively overwhelmed it. The desert, vast and unforgiving, rewarded those who could keep armies supplied across great distances. Axis forces, dependent on tenuous supply lines stretching from Europe, found themselves outpaced not only in numbers but in endurance. Fuel, spare parts, and ammunition arrived for Allied forces in quantities that defied the natural constraints of the theater. Over months, the logistical equation became inescapable. Even skilled commanders could not maneuver an army that lacked the sustenance of war. The eventual collapse of Axis resistance in Tunisia bore the unmistakable imprint of an industrial power reaching across seas. Meanwhile, across the Pacific, a different form of expansion unfolded. American shipbuilding, now operating at full wartime velocity, allowed operations across multiple island chains simultaneously. Amphibious assaults, once spaced by months of preparation, now followed each other in rapid succession. Carriers appeared in battle groups that grew more numerous by the season, their decks lined with aircraft produced in factories that never slept. The ocean, once a barrier, became an operational highway. Material abundance made it possible to fight on broad fronts without weakening any single one, a luxury no Axis nation possessed. On land, ammunition stockpiles reached levels that altered the conduct of ground warfare. Artillery units, once cautious in expenditure, began to fire with sustained intensity. Offensive operations no longer stalled for lack of shells. Divisions entered combat knowing that, for the first time, supply trains stood ready with reserves that ensured firepower could be applied hour after hour, day after day. Axis units, deprived of equivalent supplies, found themselves unable to match the density of Allied bombardments. The battlefield shifted from one of measured engagements to one of overwhelming pressure. Air superiority followed this same pattern of material continuity. The relentless arrival of fighters and bombers, P-38s, P-47s, P-51s, B-17s, B-24s, created a sky increasingly dominated by American engines. Replacement aircraft arrived faster than losses accumulated, enabling Allied commanders to plan with confidence that no single battle could exhaust their air strength. The skies over Europe and the Pacific began to tilt not through dramatic breakthroughs, but through the steady, cumulative presence of aircraft that seemed to replenish themselves. Air war, once defined by scarcity, became defined by sustained capability. By the end of 1943, the lesson was unmistakable. Quantity had become strategy, not merely support. The United States had built more than weapons. It had built momentum, the kind that alters plans, reshapes alliances, and forces the enemy to confront equations it cannot solve. And as the next stage of the war approached, this momentum would move from reinforcing fronts to breaking them. By mid-1943, a quiet acknowledgement began to take shape within the Axis high commands, an admission not declared publicly, yet present in the tone of internal reports and the guarded phrases of staff briefings. German officers, long accustomed to describing the United States as inexperienced and disorganized, now shifted their language. They spoke of American material strength as something mechanically infinite, a reservoir that seemed to deepen rather than diminish as the war intensified. What began as curiosity turned into alarm, and what had once been dismissed as industrial chaos now appeared as an emerging storm, impossible to evade. Japanese analysts reached a similar conclusion, though the path was different. In Tokyo, naval planners examined tonnage charts and ship construction timetables, plotting their own output against the surging American numbers. The arithmetic grew more unforgiving with each passing month. Japan's shipyards, burdened by limited steel and aging infrastructure, could not approach the scale achieved by American yards operating day and night. Reports circulated through staff offices warning that the empire's industrial base could not sustain a protracted struggle, not when its opponent replaced losses faster than Japan could record them. What initially looked like a clash of fleets was becoming a confrontation of capacities, and only one side possessed the depth to endure. The Battle of the Atlantic revealed this change first in the water. German U-boat crews, once confident their predatory advantage would starve Britain into collapse, found themselves overwhelmed by escort vessels arriving in numbers that defied previous intelligence estimates. Corvettes, destroyer escorts, and escort carriers flowed into the convoys with a frequency that made losses feel irrelevant. Submarines increasingly encountered not isolated convoys, but webs of protection, backed by radar, sonar, and aircraft whose presence grew more constant with each crossing. The U-boat arm began to falter not due to sudden innovation, but because American shipyards delivered vessels faster than the Atlantic could claim them. The ocean that once favored the hunter now favored the side that could rebuild. Above Europe, strategic bombing campaigns added another layer to the Axis dilemma. American bombers, powered by the industrial resurgence of the Midwest and West Coast, arrived in waves dense enough to challenge even the most determined Luftwaffe defenders. Each week, factories in Essen, Hamburg, and Schweinfurt suffered damage that Germany sent rugged to repair. Machine tools destroyed in a single raid took months to replace, Workers dispersed by air raid alarms lost hours that production statistics could not conceal. Even as new defensive tactics emerged, the pressure mounted. Bombing was not simply destroying infrastructure. It was overwhelming a system already forced to choose which shortages mattered least. The Axis found itself fighting not one enemy, but the cumulative weight of an opponent whose factories existed beyond the reach of its aircraft. Across the broader conflict, the contrast between Allied surpluses and Axis austerity sharpened into a defining feature of the war. Allied depots brimmed with crates of ammunition, spare engines, medical supplies, and vehicle parts. Axis armies, in contrast, rationed fuel, salvaged damaged equipment for parts, and stretched dwindling resources across fronts that demanded more than the economy could supply. The disparity shaped strategy as surely as any battlefield maneuver. German tank crews conserved shells. American units fired them in volumes unimaginable on the Eastern Front. Japanese pilots launched missions knowing replacements for downed aircraft were uncertain. American pilots trained in states where new aircraft waited in rows that stretched beyond the horizon. Within the Axis command structures, a realization emerged that the war had shifted from a contest of armies to a contest of economic architectures. Factories, shipping lanes, refineries, and assembly lines had become the true battlegrounds, and it was here that the Axis coalition found itself at a structural disadvantage. The brilliance of tactical commanders could no longer offset shortages of oil, steel, aircraft, and trained replacements. The enemy's strength lay not merely in numbers, but in the machinery that produced those numbers with relentless regularity. The war was no longer defined by the front line, but by the capacity to sustain one. And so the turning point of the global conflict was not a single battle, not Stalingrad, not El Alamein, not Midway, though each carried its own significance. It was the moment the Axis understood that the industrial tide had risen beyond their ability to counter. It was the recognition, spoken quietly in war rooms and written between the lines of dispatches, that the outcome had shifted from uncertain to inevitable. In the next chapter, that inevitability would take shape in operations. Vast, coordinated, and fueled by an industrial power whose momentum no longer required belief, only direction. The invasion of Normandy, often remembered for its heroism on the beaches, owed its success to forces far beyond the shoreline. Beneath the thunder of naval guns and the courage of infantrymen lay the quiet, relentless contribution of American factories. The landings did not succeed because troops reached France. They succeeded because vehicles, fuel, and ammunition arrived behind them in volumes that dwarfed anything the German defenders could counter. In the weeks after D-Day, the ports and artificial harbors filled with endless convoys carrying trucks, jeeps, bulldozers, tanks, and millions of gallons of gasoline. The liberation of Europe would march on wheels built months earlier in plants thousands of miles away. Victory, in its earliest foothold, was already shaped by logistic certainty. For Allied soldiers moving through Normandy's hedgerows, the abundance felt almost uncanny. Supplies arrived so quickly, and in such quantities that troops joked they appeared as if from nowhere. If a unit needed rations, crates materialized by the hundreds. If vehicles required fuel, tankers rolled forward in columns so long they seemed to have no beginning. Wounded men received medical supplies without delay. Exhausted infantry swapped worn boots for new ones delivered in stacks. Even as German units fought with determination, the contrast grew sharper with every passing day. The American advance was not only an act of arms, but an expression of depth, an industrial tide that sustained momentum no counterattack could disrupt. Across the Pacific, the same logic operated at an even more dramatic scale. Island campaigns that once seemed impossible expanded with a confidence born from shipbuilding power unimaginable in 1941. Amphibious transports, repair ships, supply vessels, and carriers converged on distant atolls in task forces that grew larger with each operation. No single island could absorb the full weight of this logistical structure. When one campaign ended, fleets simply pivoted to the next objective, supported by a reservoir of ships that continued to rise behind them. American industry had created the strategic equivalent of a moving continent, one that advanced not by proximity, but by production. In the air war, the relationship between industry and operations was equally decisive. Strategic bombing gained its force not from the perfection of any single raid, but from the constant replacement of Ost aircraft. Each mission demanded courage, each loss was a tragedy. Yet behind every bomber that failed to return stood another freshly assembled machine waiting at a stateside airfield. The Luftwaffe, constrained by shortages of fuel and aircraft, bled strength that could not be replenished at the same rate. American air power grew not linearly, but cumulatively. The skies became a ledger in which one side added columns while the other struggled to erase deficits. Tank divisions, the backbone of Allied mobility on land, also drew their endurance from the industrial chains behind them. Mechanized warfare consumed parts at alarming rates, tracks wore out, gearboxes failed, engines seized under constant strain. Yet repair units, supplied with parts produced in staggering quantities, kept armored formations moving. Field depots received entire engines shipped in crates, workshops rebuilt vehicles that would otherwise have been abandoned. The operational tempo of armored divisions across France and into Germany was not solely a triumph of tactics. It was the achievement of maintenance crews, supply officers, and factories working in silent synchrony. Artillery, often overshadowed by the drama of tanks and aircraft, delivered another decisive advantage. American forces possessed not only more guns, but more shells, millions more. This abundance allowed for barrages of sustained intensity, shaping battlefields before infantry ever advanced. German units, constrained by rationed ammunition, could not respond in kind. Each Allied barrage reflected not just superior planning, but the manufacturing might that ensured every cannon had what it needed, whenever it needed it. Firepower became the audible expression of industrial supremacy. By the war's final months, it was clear that victory was not the result of a single moment, invention, or battlefield triumph. It was the summation of millions of decisions, engineers adjusting tolerances, welders perfecting seams, logisticians charting routes, chemists refining alloys, and factory workers completing tasks that rarely earned headlines yet collectively shaped the fate of nations. And as the conflict neared its end, the world stood on the edge of understanding what this industrial awakening truly meant for the peace that would follow. When the guns finally fell silent in 1945, the United States emerged from the war profoundly altered. Its industrial landscape, once uncertain, fragmented, and cautious, had become a vast, disciplined system capable of constructing the largest war machine in human history. Factories that had struggled to meet early quotas now measured output not in thousands, but in millions. The experience left an imprint deeper than steel or statistics. It reshaped the national mentality, embedding a belief that complex problems could be overcome through organization, ingenuity, and scale. American industry entered the post-war world with a confidence forged in the crucible of necessity. This transformation accelerated in unexpected ways as millions of veterans returned home under the promise of the GI Bill. The legislation, intended to ease reintegration, became a catalyst for an economic shift unlike any in history. Wartime workers and former soldiers attended universities, studied engineering and science, and carried wartime discipline into peacetime industries. They brought with them a familiarity with machinery, logistics, and teamwork, skills sharpened in factories, workshops, and battlefields. As they pursued higher education and technical training, they bridged the gap between wartime production and post-war innovation, enabling industries to pivot from tanks and bombers to refrigerators, radios, and automobiles at a pace unimaginable in the 1930s. The dawn of the Cold War found the United States standing atop an industrial foundation built during the struggle against the Axis. The infrastructure assembled for global conflict, ports, rail networks, refineries, machine tool plants, research laboratories, became the backbone of the emerging rivalry with the Soviet Union. Manufacturing capacity that had once supplied Lend-Lease and field armies now turned toward early jet engines, nuclear research, radar systems, and long-range bombers. The new struggle did not require mobilization from scratch. It simply activated the machinery already in place. The Cold War began not with improvisation, but with inheritance. Veterans who re-entered the workforce discovered that their old jobs had changed. Wartime processes, statistical quality control, standardized parts, modular construction, and assembly line precision had migrated into civilian manufacturing. Factories that once prized craftsmanship now prized consistency. Materials pioneered in military laboratories found new uses. Alloys became components of household appliances. Synthetic rubber became part of everyday life. Electronics once used for targeting and communication became the seeds of consumer devices. The line between military and civilian technology blurred, making peacetime industry the continuation of wartime innovation by other means. In the decades that followed, aviation, electronics, and chemicals entered a golden age powered by the research foundations laid between 1941 and 1945. Jet travel emerged from wartime engineering, transistor research, accelerated by military need, ignited the future of computing. Chemical advances that had supported explosives, fuels, and plastics yielded entire new industries. Behind each civilian breakthrough lay the hidden architecture of wartime laboratories, procurement offices, and engineering teams who had been trained to solve problems on unforgiving timelines. Innovation, once compelled by survival, became the engine of prosperity. The concept of the arsenal of democracy itself evolved into a model for global industrial cooperation. Allied nations, having witnessed the power of coordinated production, adopted similar systems in the reconstruction of Europe and Japan. The Marshall Plan, NATO logistics, and early international trade agreements all reflected lessons drawn from wartime supply chains. The idea that economic collaboration could sustain peace drew directly from the wartime experience of manufacturing not only weapons, but alliances. In later years, historians would debate the origins of the post-war economic miracle. Some argued that prosperity was born in victory, the natural result of a nation emerging intact from global devastation. Others looked deeper, suggesting that prosperity was born in sacrifice. In the long nights of factory workers, the shortages endured at home, the industrial risks taken before success was guaranteed. They noted that the miracle was not inevitable, but earned, one decision, one improvement, one machine at a time. And as future generations assessed the war, they understood that the arsenal of democracy had done more than supply battles. It had created a blueprint for how nations transform under pressure, one whose final implications would unfold long after the last rivet was driven and the last assembly line slowed to peacetime rhythm. In the years after the war, as historians sifted through documents, production charts, and eyewitness accounts, one truth surfaced with greater clarity than the rest. America's industrial triumph had revealed the extraordinary power of unity under pressure. The factories, fields, laboratories, and shipyards did not act independently. They moved together, synchronized by a collective understanding that the survival of the free world depended on their cooperation. This unity was not abstract. It was physical, measurable, and visible in every assembly line that ran through the night, in every machine built faster than estimates predicted, and in every worker who believed that the smallest task might carry the weight of victory. For millions of citizens, participation in the war effort meant labor rather than combat. They never saw a trench or an airfield or a battlefield scarred by artillery fire, yet the weight they carried was its own form of warfare. Factory workers lived with the pressure of deadlines measured not in hours, but in lives. Farmers grew crops that fed armies on 2 continents. Railroad crews guided trains loaded with weapons destined for distant fronts. Their contribution lacked the immediacy of gunfire, but the consequences were unmistakable. Without them, the front line would have collapsed long before a single battle could be won. Gradually, the story of the arsenal of democracy became a reminder that courage does not belong solely to soldiers. It can emerge in factories where hands repeat motions thousands of times a day, in drafting rooms where engineers revise designs through exhausted hours, in supply depots where clerks track the movement of parts with the knowledge that a single missing item could stall an entire division. These acts lacked the drama of the front, yet they demanded a quieter, steadier resolve, the courage to persist, to adapt, and to confront the scale of a war fought through logistics as much as through arms. The wartime economy demonstrated how societies can transform when purpose replaces comfort. America did not drift into its industrial miracle. It willed itself there through rationing, retooling, shared sacrifice, and acceptance of hardship. Consumer goods disappeared. Luxuries vanished. Families adjusted to shortages and uncertainty, but purpose filled the space where comfort had once dominated. The shift reshaped daily life, turning routine labor into a national mission and transforming factories into the symbolic heart of that mission. The economic sacrifices were immense, but they revealed a collective capacity that peacetime had never required. As operations matured, the war revealed another lesson, one drawn not from battlefield maneuvers but from the discipline of planning. Victory grew from schedules, blueprints, inventory charts, and coordination. Systems refined through trial and error. It was the triumph of preparation over impulse, of structure over improvisation. Battles depended on supply lines established months earlier. Missions relied on spare parts ordered long before pilots climbed into cockpits. The war taught that even the boldest strategies required logistical foundations more intricate than any single commander. In this sense, the industrial war rewarded foresight as much as courage. The legacy that emerged then was not confined to the weapons built. It lived within the resolve they represented, the willingness of a society to confront a global threat with intellect, labor, and unity. Tanks, aircraft, ships, and shells became symbols of something deeper. The belief that free nations, when fully mobilized, could meet the demands of history without surrendering their character. The arsenal of democracy was not only a collection of factories. It was a declaration of what a nation could accomplish when its people accepted responsibility for the fate of the world. And as the final evaluation of the war settled into the pages of history, one conclusion became inevitable. The machines may have shaped the battles, but the moral force behind them shaped the century that followed. They built it to win a war. It ended up rewriting history.